In this video, we're going to talk about the multiplication of radicals. Before we do that, let's talk about the product rule for radicals. Let the nth root of a and the nth root of b be real numbers, and n greater than or equal to 2 be an integer. Then the nth root of a times the nth root of b is equal to the nth root of ab. Remember, to multiply radical expressions, the indices of the radicals must be the same. So let's multiply the radical expressions and simplify. So first off, I'm going to multiply the two numbers that are outside the radical. So 3 times 5 is 15. Multiply the two numbers under the square root. So the square root of 2 times the square root of 6 is the square root of 12. Now, are there any perfect roots I can pull out of 12? After pulling out the perfect roots of 12, I have 2 times the square root of 3. So I'm going to replace the square root of 12 with 2 times the square root of 3. 15 times 2 is 30 times the square root of 3. All right, let's do one other example with a fourth root. So again, I'm going to multiply the two numbers outside the radical first. Negative 3 times 6 is negative 18. 9 times 9 is 81. A squared times a to the 7th. When you multiply exponents with the same base, you add the powers. So that's a to the 9th. B cubed times b to the 8th. That's b to the 11th. Now, let's pull out all the perfect roots. So pulling out the perfect roots, we have 3a squared b squared times a fourth root of a b cubed. So let's do this then. Negative 18 times we just pulled out. Not much left to simplify. Negative 18 times 3 is negative 54. All right, so before we do the next example, let's review very quickly on how to simplify this algebraic expression. So we have a monomial times a binomial. So I would distribute the negative 8 to the 3x and the negative 8 with the negative 4. That's negative 24x plus 32. All right, so now let's do this with a radical expression. So here I'm going to take the 3 times the square root of 11 and multiply by 2 times the square root of 2. 3 times 2 is 6. Square root of 11 times the square root of 2 is the square root of 22. Distribute. 3 times 1 is 3. Square root of 11 times the square root of 11 is 11. And then 3 times 11 is 33. Now, there's something very important that we can get out of this. So the square root of 11 times the square root of 11, which is the square root of 121, which is 11. The square root of 5 times the square root of 5 is the square root of 25, which is 5. The square root of 6 times the square root of 6 is the square root of 36, which is 6. So in general, the square root of a times the square root of a is the square root of a squared, which is a. So I'm going to write that over here. This will be very, very important later on. All right, so before we continue to multiply radicals, let's multiply this binomial times this binomial. So how did we do that earlier? We FOILed. 3x times 3x is 9x squared minus 12x minus 6x plus 8. Combine the like terms, and we get this. Now, we can do the exact same thing for these radical expressions. When we have a binomial times a binomial, we FOIL. So, 3 times 5 is 15. Square root of x times the square root of x, that's going back to this statement. 3 times 3 is 9. Square root of x times the square root of y is the square root of xy. Negative 4 times 5 is negative 20. Square root of y times square root of x is the square root of xy. Negative 4 times 3 is negative 12. Square root of y times square root of y is y. Again, we're going back to this in general rule. Combine like terms. There are no other like terms or like radicals. We're done here. All right, one other example I want to multiply. Again, I have a binomial times a binomial, so I'm going to FOIL. So 6 times 5 is 30. Square root of 6 times the square root of 6 is 6. 6 times 2 is 12. Square root of 6 times the square root of 10 is the square root of 60. 1 times 5 is 5. Square root of 10 times square root of 6 is the square root of 60. 2 times 1 is 2. Square root of 10 times square root of 10 is 10. So we know 30 times 6 is 180. Combine like terms. And 2 times 10 is 20. 180 plus 20 is 200. Now, the last thing we need to check is, are there any perfect roots I can pull out of 60? In this case, when we pull out the perfect roots, I have 2 times the square root of 15. So, replace. And 17 times 2 is 34. Don't forget the square root of 15. These are not like terms here. We're done.